GC 2010 installation. Following facilities are required for the successful and correct installation of GC 2010. If these facilities are not fulfilled, don't go for unboxing and installation. Leakage voltage test procedure in power source. Before starting unboxing and installation, must verify leakage voltage in power source, as per procedure. First, check voltage between line and neutral, that should be 230 volt AC, plus or minus 10 volt. Check voltage between line and earth, that also should be 230 volt AC, plus or minus 10 volt. Check voltage between neutral and earth, that should be less than 0.5 volt AC. If the power source is not correct, don't go for unboxing and installation. Unboxing and material verification, as per packing list. Once all the installation availabilities are confirmed, then go for unboxing and material verification, as per packing list. The boxes are already received, in well-packed condition as per picture. After unboxing the system, you must check all the material as per packing list. In case of any shortage or discrepancy, immediately contact to organization by audio or video call. Set up the instrument on vibration-free table or platform for the sturdy operation of the instrument. Introduction of GC 2010. This is complete setup of GC 2010. This instrument is configured as a dissolved gas analyzer. It is also called DGA. DGA is being used for the analysis of gases are dissolved in transformer oil, and to prevent sudden breakdown of transformer. This is pneumatic panel of the instrument. These two are carrier 1 and carrier 2 flow controller valves. These two gauges shows the pressure of carrier 1 and carrier 2 gases. This is hydrogen gas flow control valve. This shows the pressure of hydrogen gas. This is zero air flow control valve. This shows the pressure of zero air. These slots are kept blank for future modification and system configuration expansion. This is column oven in close condition. Take a look inside the oven. Press this lever to open oven door. Two packed columns are installed inside the SS oven for DGA application. These are electronic modules. This is temperature programmer module to provide temperature different parts of the GC. This is FID high gain amplifier module to amplify the signal received from FID detector. This is TCD amplifier module to amplify the signal received by TCD detector. This is timer programmer to program FID and TCD signal timings. This is data acquisition module to convert analog signal into digital signal. This is top lid portion of the instrument. After opening the top cover, all assemblies can be seen. This is injector number 1. This is injector number 2. This is FID detector. This is methanizer. This is TCD detector. This is terminal box, where all the electrical connections are made. Cylinder arrangement, and regulator mounting. After unboxing the cylinders, arrange it as per sequence. First put nitrogen cylinder, hydrogen cylinder, and then zero air cylinder. Take out regulator from the box and put only 4 turns of Teflon tape on regulator connector. Insert connector firmly into the zero air cylinder valve. Turn regulator nut clockwise by hand. Don't use spanner directly to tighten the regulator nut. Forcefully tightened nut could damage the threads. Use adjustable spanner to tighten the nut. Keep regulator gauges front facing for easy monitoring. Insert connector firmly into the hydrogen cylinder valve. Turn the regulator nut anti-clockwise by hand. Reverse threaded nut is used in hydrogen cylinder. For the safety purposes, cut mark shows it has reverse threads. Use adjustable spanner to tighten the nut. Keep regulator gauges on front facing. Insert connector firmly into the nitrogen cylinder valve. Turn the regulator nut clockwise by hand. Use adjustable spanner to tighten the nut. Keep regulator gauges on front facing. All the 3 regulators are mounted properly. Read this safety note when working with the hydrogen cylinders. Stainless steel tubing connections to cylinder regulators. These seamless tubes size is 1 by 8 inch OD, specially made and processed for chromatography instruments. These tubes are used for external connections of instrument. Stainless steel tubing are packed in round shape for easy and safe transportation. All tubes should be straight before connecting to the cylinder regulator for proper connection. Make all the tubes straight by hand only. Don't use hammer or other solid tool to straight the tubes. Straighten all the tubes in required length before connection. Procedure to bite ferrules on SS tubes. Keep the tube horizontally, insert nut, back ferrule, then front ferrule on SS tube. Insert this tube into the regulator connector. Keep tube in straight position while biting the ferrule. Turn the nut clockwise by hand only. Don't use spanner directly to bite the ferrule. After tightening the nut by hand, use 11 number fixed spanner to tighten the nut. Rotate spanner only half turn. Do not over tight. After biting the ferrule, remove tube out, and put Teflon tape on ferrule set. Apply only 4 turns of Teflon tape on the ferrule set. Don't apply more Teflon tape. Excessive Teflon tape could stuck into the nut. Reinsert tube into the regulator connector and turn nut by hand. Use 11 number spanner to tighten it again. Repeat these steps to bite ferrule on SS tubes needed for the installation. Connection of carrier gas tube to the instrument. Here we are using nitrogen gas as a carrier. Connect nitrogen gas tube to the carrier bulkhead of the instrument, same way, bite ferrules, and put Teflon tape on SS tube, as per previously mentioned procedure. Then connect hydrogen and zero air tubes. Ferrule set biting procedure, on flexible tube. If you are using flexible tube, instead of stainless steel tube, for the connection, between cylinders and instrument. Keep tube in horizontal position, then insert nut, back ferrule and front ferrule, on flexible tube. Insert this tube, into the regulator connector. Keep tube in straight position, while biting the ferrule. Turn the nut clockwise by hand only. Don't use spanner directly, to bite the ferrule. After tightening the nut by hand, use 11 number spanner, to tighten it. Rotate the spanner only half turn. Don't over tighten it. After biting the ferrule, remove tube out, and put Teflon tape, on the ferrule set. Apply only 4 turns, of the Teflon tape on ferrules. Don't apply more Teflon tape. Reinsert tube, into the regulator connector. And turn the nut by hand. Use 11 number spanner to tighten it again. Difference between over-tighten and normally tighten ferrules on flexible tube. Over-tighten ferrule looks pinched and partially blocked. It can restrict the pressure of the gas. So don't over-tight the nut. How to arrest leak on pneumatic connection. Open the cylinder valve with the help of cylinder key. Turn the cylinder key anti-clockwise direction to open it. Right side gauge shows the inlet pressure of the cylinder. Adjust the outlet pressure by regulator, turning it clockwise. Set it to 5 kg per centimeter square. Now put the soap solution, with the help of small brush on the newly connected tube. Bubbles can be seen, on the connection, if leakage is present. Use 11 number spanner, to tighten the nut slightly. Don't over-tight the nut. Again put soap solution, and confirm that leak is arrested. No leakage, after tighten the nut. Clean that area, with dry cotton cloth, to avoid rusting in future. Repeat this step, to arrest the leakage, on all newly connected tubes, regulators, and other connections. External electrical cable connections, of electronic modules, in GC 2010. These cable assemblies need to be connect, between instrument, and electronic modules. Connection of temperature controller cable, from temperature controller to instrument. Match the both connector pins as shown. Wrong connection could break the connector pins, so carefully plug in the connectors. Match the pins and just press it. Connection of TCD filament cable, from TCD amplifier module to instrument. Connection of all power cables, from 230 volt AC power socket of modules, to power source, servo stabilizer or supply board. Connection of pressure switch cable, from TCD amplifier to instrument. Keep notch upward side, and turn the connector cover clockwise. Connection of detector cable, and HT cable to FID amplifier. Match the cable socket, with module's connector socket, and turn it half round only. Match the color code, as per picture. Wrong connections could damage the electronic PCB of the FID amplifier. Signal connection between timer module and TCD amplifier. Match the polarity as per picture. Use small screwdriver to open and close the screws of terminals. Signal connection between timer module and FID amplifier. Match the polarity as per picture. Connection of data acquisition module. Red and black wire connect to DAS input connection on timer module terminal strip on pin number 8 and 9. Must connect as per polarity shown in the picture. Two gray wires connect to external trigger terminal strip on timer module, polarity not required. Connect black round pin cable to data acquisition module's input socket. Connect USB cable to any USB 2.0 or 3.0 port of computer. Don't connect serial cable if USB connection facility is available in the computer. Control knobs and keypad operation of electronic modules. Overview of rear panel and cable termination. This is digital temperature programmer module with real-time display. This is digital display where set point and set values can be seen. This is keypad control to set the temperature, heating on off, and status indicators. This key is used to set the temperature of oven. This key is used to control heating on and off. This key is used to set the temperature of methanizer. This is numeric keypad to enter the numeric values of temperature set points. These red LEDs are states that heating is on for these two zones. This LED states that heating control is on. If this control is off, temperature will not rise. These are safety cutout indicators. It operates when any zone cross the maximum temperature values. If any one of these safety cutout is operated, temperature control will be off, and it will stop the heating. This key is used to mute the beeping sound of any alarm, and to be escaped from any menu. This is temperature controller modules, rear view, where all the electrical cables are connected. This is AC supply input power socket. This is power on and off switch. These are fuses. This is MC16, heater cable socket. This is D15 sensor cable socket. These two connectors are not used in this application. This is FID high gain amplifier module. This is power on and off LED indicator. It states that module is power on or off. This is balancing pot. This pot is used to adjust the FID amplifier baseline balancing to 0. This is low and high sensitivity selector switch. This selector switch for the selection of low and high sensitivity of the amplifier. This is AC supply input power socket. This is power on and off switch. This is FID detector, HT cable female socket. This is FID detector, collector cable female socket. This is fuse. This is FID amplifier, output terminal strip. This is TCD amplifier module. This is power on and off LED indicator. It states that module is power on or off. These are fine balance and coarse balance pots. These pots are used to adjust the TCD amplifier's baseline to 0. This is TCD filament current setting pot. This pot is used to adjust the TCD detector's filament current. Set filament current 70 mA in argon carrier gas, and set filament current 100 mA in nitrogen carrier gas. This display shows the TCD detector filament current in milliampere. This switch is used to change the polarity of TCD detector. This is AC supply input power socket. This is power on and off switch. This is fuse. This is TCD amplifier, output terminal strip. This is TCD detector, D9 male socket. This is timer programmer module. This is start button, to start the analysis, after sample injection. This is stop button, to stop the analysis. This is power on and off LED indicator. It states that module is power on or off. This is digital timer, where the time is visible during the cycle time. This is mains input, AC power supply cable. This is fuse. This is power on and off switch. This is TCD amplifier signal connection terminal strip. This is FID amplifier signal connection terminal strip. This is data acquisition signal connection terminal strip. Terminal number 3, 6, 9, and 10 are not connected with any cable. This is external trigger, signal connection terminal strip. Switching on procedure of GC 2010. Cylinders are ready, after tubing connection, from cylinder regulator, to instrument. First open nitrogen cylinder valve, with the help of cylinder key. Turn the cylinder key anti-clockwise to open it. Right side pressure gauge shows the inlet pressure of cylinder. Adjust the outlet pressure by regulator, turning it clockwise and set it to 5 kg per centimeter square. Open hydrogen cylinder valve, with the help of cylinder key. Turn the cylinder key anti-clockwise to open it. Right side pressure gauge shows the inlet pressure of cylinder. Adjust the outlet pressure by regulator, turning it clockwise and set it to 5 kg per centimeter square. Open zero air cylinder valve, with the help of cylinder key. Turn the cylinder key anti-clockwise to open it. Right side pressure gauge shows the inlet pressure of cylinder. Adjust the outlet pressure by regulator, turning it clockwise and set it to 5 kg per centimeter square. After setting of all regulators, output pressure at 5 kg per centimeter square. This is the pneumatic panel of the instrument. Verify all the pressures as per yellow tag located on the instrument. If required, then only adjust the pressure by this flow control valves. Turn the flow control valve anti-clockwise to increase the pressure, and turn it clockwise to decrease the pressure. Set the exact pressure as per yellow tag for the best results. Ignite the flame in FID detector by igniter. Open the detector cap by turning it anti-clockwise, and click igniter 3 or 4 times, to ignite the flame. Return back the FID cap on detector, by turning it clockwise. Do not over-tight the cap, just stop turning, when threads are finished. Verify the flame, by putting igniter shiny tip on the FID detector. If flame is ignited, then vapor can be seen on it. If vapor not visible, then again repeat the same process. Power on all electronic modules as per sequence. Power on switches are located at back of all modules. First switch on the temperature controller module. Then switch on FID amplifier module. Then switch on TCD amplifier module. Set the filament current to 100 mA on nitrogen carrier gas. Turn filament current pot clockwise gradually, to increase the filament current. Don't increase it more than 100 mA. Switch on the timer module. Set the oven temperature to 40 degrees centigrade. To set, press oven key, and enter value 40, then press enter key. After setting of temperature, press escape key, to return main menu. Set methanizer temperature to 280 degrees centigrade. Press detector 2 key and enter value 280, then press enter key. After setting of temperature, press escape key to return main menu. Press heating on key, to start the heating. Temperature will start to increase and can be seen on display. Allow the instrument at least 45 minutes of stabilization time. Software basic operation and baseline adjustment of TCD amplifier and FID amplifier. First, create new folder, where we want to save all the analysis files. For example, folder name is 05052121. Double-click on PKBC shortcut icon. There is no user ID and password in software, so click on OK. Software analysis window is open and check for green button. It confirms that communication is OK between ADC module and computer. Click on Option button to allocate the path to save all the analysis files in that folder. Select Channel A, then click on Files are saved to folder. Select the folder name, which was created earlier on desktop, 05052121, then click on OK. Close the pop-up menu. Set the analysis time, 15 minutes. Analysis time varies on the basis of flow settings and column length. This time is given only for example. The analysis time will be finalized after final settings of the instrument. Press Start button of timer module. Set baseline nearest to 0, positive side, in FID and TCD amplifier. The analysis is started, and timing can be seen on timer module. First adjust the baseline of TCD amplifier. Turn the fine balance, or coarse balance clockwise, to set the baseline positive side, and set negative side in anti-clockwise. You can see the effect of adjustment on software screen. Baseline values can be seen on the analysis window at bottom right side. Same way adjust baseline in FID amplifier, by turning balance pot clockwise to set the baseline positive side, and set negative side in anti-clockwise. Click on Stop button after setting up the baseline. This procedure is explained if baseline is disturbed by mistake, and someone turned the balancing pots. No need to adjust the baseline every time, during switching on the instrument. Standard or calibration gas sample collection, from cylinder, and injection with gas-tight syringe, in the injector. Here we are using 2 ml gas-tight syringe to collect the gas. Don't use liquid syringe for gas samples. Keep the syringe in horizontal position, apply finger support under the needle, and palm support at the end of plunger. Slowly insert the needle into the standard gas cylinder outlet rubber septum nut. Take the standard or calibration gas, at least 3 times, into the syringe and flush it into the atmosphere, to avoid previous sample contamination, or wrong results. After 3 times flushing in atmosphere, finally take 1 ml gas, and inject into the instrument's injector number 1. Then press Start button of timer module. Acquisition will start, and graph can be seen on analysis window of software. Analysis graph. Video is in fast forward mode, for demo purpose only. Actually it will take 15 minutes, or instrument's final time settings, to complete the analysis. Zoom the graph by pressing and dragging mouse left key. Zoom the graph 2 or 3 times to see the proper baseline. This is hydrogen gas. We need to integrate it properly. Zoom out by double-clicking mouse left key. Unwanted and additional peaks must be removed with proper integration and parameters. Click on Integration tab. Zoom the graph for proper baseline visibility. Right-click on Nearest to Start Time. Select Start to ignore peaks. All peaks will be ignored. Integrate the parameters as per procedure. Select the time and press backspace key from PC keyboard to remove the time. Zoom the graph again. Put the mouse cursor at starting point of first peak and press mouse left key. Then select Start to treat peaks separated option from pop-up menu. All peaks are integrated properly. After integration, to apply results, then click on Calculate button. Zoom the graph 3 or 4 times, and check for proper integration. Procedure: to make component table and naming of the peaks are detected. Click on Component tab. Click on Fetch Time and then click on Yes, to get the retention time of all peaks to enter the name one by one. Enter the peak name in component table as mentioned peak order. H2, CO, CH4, CO2, C2H4, C2H6, and C2H2. Click on Calculate button to apply the changes and add naming in result table. Integration and naming is done properly. Naming are visible under the peak. How to save template or method file after setting up all the parameters and proper integration. Click on File menu, select Save Template. Enter the file name, for example, 500 ppm standard gas. Then click on Save button. After new analysis, to load template which was saved earlier, from File menu. Click on Load Template. Select 500 ppm standard gas template file. And click on Open button. Click on Calculate button, to add name in component table. All the parameters and naming will be set automatically. This parameters will be applicable for all the upcoming analysis, and data will be updated in result table. At last, don't forget to click on Save button. DGA interpretation software operation, calibration with standard gas, and find ppm value in oil. After getting repeatable results from standard gas, enter these area values in DGA interpretation software to calibrate the instrument. Note down all the areas of standard gas, minimize current window. Double-click on CIC DGA icon to open interpretation software, click on DGA, click on Continue. Select PDG and Duval's triangle, then click on Continue. Click on Oil Analysis, fill all asterisk marked compulsory fields, for example, enter 1 in all asterisk marked fields. Don't change data of these fields. Click on ppm using area, Enter these values in area in standard column. Enter standard ppm values from standard gas canister in ppm of standard column. Fill all the data in respective fields. Enter any value, for example, 100, in all area in sample column, to save the calibration, and to recall it in future. Click on Calculate, to save the record, and to recall it, in future. Click on OK. Find ppm value, in oil, with DGA interpretation software. Graph of gases extracted from oil sample. Collect area values, and feed these values in DGA interpretation software. Note down all the area values of extracted gases. Minimize current window. Double-click on CIC DGA icon. Click on DGA, click on Continue. Select PDG, and Duval's triangle, then click on Continue. Click on Oil Analysis, fill all asterisk marked compulsory fields. Enter volume of extracted gas, from glass extraction apparatus, in volume of gas extracted column. Don't change data, of other three fields. Click on ppm using area. Click on Recall Previous Data, all calibration data will be restored, in first two columns, as per previous calibration. Enter obtained area values, of oil sample in, area in sample column. Put 0, if the component is not detected, by the system. Sequence of peak order obtained by the DGA, and software is different, therefore enter all the values carefully in software. Click on Calculate, to save the record, and to recall it, in future. Click on OK. ppm value of extracted gases, from oil, can be seen in this column, after calculation. Click on Save Print, to take print of the generated report. Click on Printer icon, if printout is required, otherwise, close the window. Switching off procedure, of GC 2010. Press heating on and off key, to switch off the heaters. All heating zones, will start to cool down. Wait till detector 2, temperature reaches, below 100 degrees centigrade. Detector 2 zone, is used for methanizer. Never switch off the gases, without cooling down the methanizer. If gas is off, and methanizer is still heated, the catalyst of methanizer, will get burned and becomes solid. So wait till the detector 2, temperature reaches, below 100 degrees centigrade. When system is in cooling mode, meanwhile reduce the filament current, to minimum, by turning the filament current pot, anti-clockwise. Detector 2, temperature is below 100 degrees centigrade. After cooling down the system, switch off all electronic modules one by one. Sequence is not required to switch off the modules. After switching off all electronic modules, close all the gas cylinders. First release the regulator by turning it anti-clockwise. Then close cylinder valve with cylinder key. Close all the cylinders one by one. After switching off the cylinders, shut down the computer. Gas extraction from oil. Partial degassing method, with glass apparatus. This glass apparatus is used to extract dissolved gas from transformer oil. This vacuum pump is used to evacuate air from glass apparatus. This magnetic stirrer is used to heat and stir the oil. This stand is used to hold the glass apparatus. This is gas sample collection point to take the sample in syringe. This are vacuum path selection and on-off valves. This is sample oil container. This is conical flask with magnet to stir the oil. This heating control knob is used to control the heat of hot plate. This is power on and off switch of magnetic stirrer. This is RPM control knob to control the RPM of oil rotation. This is RPM display. This vacuum gauge shows the vacuum level generated by the vacuum pump. This is mercury container. Mercury is used to pressurize extracted gas. This is vacuum discharge valve to release the vacuum. This is vacuum suction tube. This is vacuum pump. Oil level indicator shows the level of oil. Gas extraction procedure from transformer oil. This is the setup of gas extraction apparatus to extract dissolved gases from transformer oil. Adding mercury in mercury container. This mercury is used to pressurize the extracted gas. Put funnel into the container and pour mercury slowly. Put container slowly on stand. Switch on vacuum pump for 5 minutes to evacuate air from the glass apparatus. Vacuum gauge pointer will move completely left side while pump is on. Switch off vacuum pump after 5 minutes of evacuation. Hold glass apparatus by hand and close vacuum inlet valve slowly. Then release vacuum pump discharge valve. Add transformer oil in container up to 50 ml of marking. Open oil discharge valve, and release 50 ml oil, in conical flask, then close the valve. Switch on magnetic stirrer, and keep temperature knob in middle, to set temperature at 70 degrees centigrade. Set stirrer RPM at 550 to stir the oil for 3 minutes. Change position of this valve slowly, to pressurize gas through mercury. Mercury will go up, and it will pressurize the extracted gas. Mercury is up to this level, and gas is above this mercury level. Extracted gas is ready for the injection. Extracted gas sample collection and injection. Take 1 ml of sample amount from sample out port. Maintain distance of syringe needle from mercury while taking the sample. Mercury level will be increase after withdrawn the sample. Inject 1 ml of sample in injector number 1 and start analysis. After taking sample, open this valve slowly, to release the vacuum. Mercury will come down, and accumulated, in container. Vial preparation method, with vial flushing jig, for oil sample, in manual headspace sampler. This are manual headspace sampler components, need to be assembled. This magnetic stirrer with hot plate, is used to heat, and stir the oil sample. This is, beaker support plate. This glass beaker, is used to store water. This is, glass vial holder. This is 20 ml glass vial, need to be flush out, with argon gas, before filling with, transformer oil. This is temperature control knob, to control the temperature of hot plate. This is temperature on, and off, indication LED. This is, RPM display. This is magnetic stirrer, on-off switch. This is, RPM control knob. This is, hot plate. Assembly of, manual headspace sampler components. Put beaker support plate, on the center of hot plate of magnetic stirrer. Put glass beaker, into the center of support plate. Then put vial holder, into the glass beaker. Assembly is ready, for heating and stirring process. Aluminum cap with silicon septum, crimping procedure, on glass vial. These are, aluminum caps, with silicon septums. This crimping tool, is used to crimp, aluminum cap, on glass vial. Put magnet inside the glass vial, before crimping, aluminum cap on it. Keep vial in vertical position, put aluminum cap on glass vial. Keep crimping tool, on aluminum cap, confirm that tool is completely seated, on aluminum cap, then press it, in 4 directions, by rotating vial. Confirm that aluminum cap, is crimped properly, and not moving by hand. If cap is moving by hand, then try to crimp it properly. Gas might be leaked from the vial, if cap is not properly crimped. Vial flushing procedure, with argon gas. Open argon gas, input toggle valve, pressure can be seen, on pressure gauge. Pressure will be 0, while opening toggle valve of vial flushing jig. It means argon is coming out, from outlet needle. Insert needle tube into the septum, as per picture, wait for 5 seconds, so vial will be slightly pressurized. Then insert exhaust needle, also into the septum. Flush the vial for 3 minutes with argon gas. After flushing with argon for 3 minutes, first remove exhaust needle, wait for 5 seconds, then remove needle tube. Vial is completely flushed with argon, and no atmospheric air inside the vial. Turn off argon inlet and outlet toggle valve. Add transformer oil after flushing with argon gas. This is transformer oil. This is 20 ml plastic syringe with needle to inject oil in glass vial. Take 20 ml oil in plastic syringe from glass container. Ensure that there is no air bubble present in oil. Remove air bubble from syringe, then only inject it into the glass vial. First insert syringe into the vial septum, then insert exhaust needle into the septum, as previously mentioned, argon flushing procedure. Inject 11 ml oil slowly into the vial. Remove exhaust needle first, then remove syringe from the vial. Vial is prepared and ready for heating and stirring process to extract the gas from oil sample. Add 120 ml normal water into the glass beaker. Switch on magnetic stirrer, wait till initialization. Set temperature knob in the middle point for 70 degrees centigrade temperature, wait for temperature set point stabilization. After temperature stabilization, put prepared vial into the vial holder located inside the beaker. Set rotation between 500 to 600 rpm to heat and stir the oil sample for 10 minutes to separate the gas from oil. After 10 minutes of heating and stirring process, reduce rotation to 0 rpm and take sample vial out. Use 2 ml gas tight syringe to collect the extracted gas sample from the vial. Insert syringe needle into the vial. Ensure that needle has not been dipped into the oil while taking the sample. Take 1.6 ml sample gas, and inject it into the injector number 1, then press start button of the instrument.